Okay. And let me start with a 20, which is an easy one, and then get to a word problem, and that should do it. Okay, let's start with A is equal to 12, and B is equal to 13, and C is equal to 5. Okay? Alright, so in this situation I don't have an angle. I just have a random triangle. We'll just make a random triangle. We'll call this A, B, C, not drawn to scale. Okay, and this is 12, this is 13, this is 5. Okay, what I have to do is I have to find all the other angles. Okay, so if you're going to make it easy on yourself, okay, so there's no confusion in terms of which angle to your calculator doesn't give you a false reading because it is restricted by sine and cosine inverse. Okay, when you start this, just go ahead and solve for the big one and get that out of the way with cosine, because you will get the correct answer always. But with sine you got to be careful because of domain restrictions. Okay, so let's solve for b. So that means we're going to use this formula: b squared is equal to a squared, okay, plus c squared minus 2ac cosine of angle b. You'll see what I mean in a second. Okay, alright, so b squared, which is 13 squared, is equal to a squared, which is 12 squared, plus c squared, which is 5 squared, minus 2 times a, which is 12, times c, which is 5, and that's cosine of angle b. Okay, 13 squared is 169, is equal to 12 squared is 144, plus, okay, c squared, 5 squared, which is 25, okay, minus 2 times 12, which is, or 2 times 5 is 10, 10 times 12 is 120, cosine of b. Okay, this is 169 is equal to 169 minus 120, okay, cosine of b. Okay, so this is going to give me, when I subtract that, that's going to give me a 0 is equal to negative 120 cosine of b, and then when I divide, my cosine of b is equal to 0. Okay, and then that means my angle b is going to be cosine inverse of 0. So this is kind of easy one too. Okay, so I'm going to go ahead and use a calculator. I don't need a calculator, you'll see why in a second. Okay, I'm going to go cosine inverse, so cosine inverse of 0. Okay, hit enter. 90 degrees. Oh, that turned out to be a right triangle, 90 degrees. Okay, so that's why, because we know on the unit circle that's where cosine is 0. So my angle b turned out to be 90 degrees. So as soon as I get that, then I can use my sine, and I don't have to worry about which side to find first, whatnot. Okay, so I can just go sine of 90 degrees is to 13 is, we can find either c or a. So let's go ahead and find c. So sine of angle c is to 5. Well, sine 90 degrees is really 1 over 13. Okay, is equal to c sine of c over 5. So sine of angle c is equal to 5 over 13. Okay, to find angle c, so c is equal to sine inverse of 5 over 13. So let's go sine inverse. Okay, sine inverse 5 divided by 13, close parentheses, make sure we get we're going to get a decimal, so I'm going to hit my approximation. Okay. and that will give me 22.6 degrees, so it'll be 23 degrees. We'll round up to 23 degrees, and that's 23 degrees. Alright, so angle C is easy now, okay, because I don't have to use law of sines or cosines, it's just geometry. So I'm going to go 23 plus 90, okay, and that's going to give me 113 degrees. So when I subtract 180, okay, and that's going to be 67, so angle C is 67 degrees. And that's it. Okay. So if you find the biggest angle first using law of cosines, everything else goes smoothly. Okay. Alright. So let's clear that, and let's do a hard one. Okay. Okay, this is number 26. We're talking about a Little League baseball diamond, and the sides are 60 feet in length, and the pitching rubber is 46 feet from the home plate. That's my pitching rubber right there, and that's my home plate. And they tell me that the line connects the home plate to the second base. So that means if I draw this diagonal all the way from the second base to home plate, since this is 90 degrees and it's a square, this is going to be 45 degrees. The question they ask us is, how far is the pitching rubber to the first base? So from the pitching rubber to the first base, we'll call that X. We've got to find that. Okay, to find that, I know this angle, that's 45 degrees. I know this side, which is 60. I know this to be 46. So I could use law of cosines, okay, because we're finding that X, so I'm going to use that angle. So I'm going to go X squared is equal to the other two sides squared, which is a 60 squared plus 46 squared. Okay, and then minus 2 times 60 times 46 times cosine of 45 degrees. Okay, so I get X squared. 60 squared is 3600, and plus 46 squared is really 40. So it's going to be 46 times 46. Okay, that is 2116. Okay, minus, okay, 2 times 60 times 40, okay, times, I have a cosine, so cosine of 45 degrees, and then I am going to get a decimal representation of that, and that turns out to be 3394. Okay, so we're just going to have to add all these up. So I have a 3600 plus 2116, then minus 3394. Hit enter. Okay, so my X squared turns out to be 2322. I'm going to take square root of that. So square root of 2322. Okay, and then we're going to hit enter, and that turns out to be X is approximately 48 feet. Okay, so that's 48 feet. Okay, we found that. Okay, so that's one of our answers. Second question, how far is it from the pitching rubber to the second base? So that means we're going to find this. So this is right here is a right triangle, and this is the hypotenuse. Okay, if I can find that, I could just subtract 46 from it, so I can find that distance right there. Alright, so that's going to be 60 squared plus 60 squared is equal to C squared, which is 3600 plus 3600 is equal to c squared. That's going to be 7200 is equal to c squared. So we're going to take a square root of that. So square root of 7200. Okay, and I sure like to have a decimal representation of that. And that turns out to be c is equal to 85 feet approximately. Okay, to find out what that distance is, I'm going to take 85 and I'm going to subtract, okay, 46 from that, okay, and that is going to give me approximately 39 feet. So this is 39 feet to the second base. So that's my other answer. Okay, so I found that answer and I found that answer. Now, the third part of this is C. If the pitcher is facing the home plate, through what angle must he turn to face the first base? So that means they want me to find that angle. Okay, so since we know this angle and we know this side, we can go to law of sines. So I can go sine of 45 degrees is to 48 is to sine, we call this angle theta. Theta is to 60 because that's opposite from that. Okay, sine of 45 degrees. So we can go to our calculator. So sine of 45 degrees. We need decimal representation of that is 0.707. So we're going to have a 0.707 over 48. Of course, when I multiply both sides by 60, I'm going to get that, which is sine is equal to sine of theta. So we'll multiply 0.707, 0.707. We're going to multiply that by 60. Okay, and then we're going to take that answer, we're going to divide that answer by 48. Okay, and I'm going to get sine of theta is equal to 0.884. Of course, we're going to have to take sine inverse of this. So my theta is equal to sine inverse of 0.884. So let's go ahead and get that. So it'll be sine inverse of 0.884, close the parentheses, okay, and that turns out to be approximately, okay, 62 degrees. So this angle here is 62 degrees to face the first base. Alright, so number 25 is done exactly like this, except the numbers are changed. Alright, okay, it's gonna do it for me. So let me stop that right here.